Hello, Shannon Flummerfeld here for Flipped Schools. Welcome to the Sustaining Improvement series. This is a series of 5 videos set up for building administrators, and we're going to explore in this particular video barriers to sustaining improvement, and then in the other 4 videos present a tool for sustaining improvement called the 5S. So I hope you'll listen to all 5 videos. Well, first of all, let's be clear about these terms, and we'll start off with the definition of what it means to sustain improvement. What we want to do here for getting to a point of being able to sustain improvement, this is also sometimes known as being able to scale or even replicate. But the idea is that if you have a structured protocol, one that's really easy to follow, that's fairly visual, then it makes it a lot easier for you as a building administrator to help faculty through this process. And so we're going to define this as a structured protocol that'll help you to capture, develop, initiate, correct, and then finally maintain success. I know that many building administrators are so tired of the repertoire of new ideas that come across, their desks. Like every semester, there's something new. But how do you actually take something that really is a good idea and fully develop it in your building so that it becomes a point of success and that it's actually sustained? And so that's what we're going to be exploring here. As you work in the flipped environment and you're flipping classrooms and you're flipping your school, as a building administrator, you'd be very in tune to the fact that there are so many things changing and there are so many opportunities for improvement. So if you have an easy protocol to follow, you'll be able to bring the best practices forward and make sure that those become a part of the DNA of your school. We're going to just take a very broad example here in examining barriers today in this video, but we'll just say, for instance, let's say that you have mathematics instruction going on in your building. You're starting to use the flip technology. Some things are working, some things are not. The mathematics department is working very hard in terms of figuring all this out. But how do you then begin to get this to a point where improvement in mathematics is sustained and it's actually really clear and shared by the faculty what works and what doesn't? So that's what we'll explore here. And of course, what we want to do now is take a look at what are some of the barriers to sustaining improvement. And so actually, what are barriers? Well, barriers might be thought of in a negative way because they are defined as impediments or failures. And what the impediment or failure occurs in is either in thinking, it's either in the paradigms that happen and that drive actions, or the actual actions that occur that are, that then reinforce a poor paradigm. And so what happens here is that it becomes a barrier because it needs to be identified as a barrier. It needs to have some root cause analysis applied to it so that it doesn't block the option to create value. So barriers essentially do that, is that there are failures in thinking or acting that we kind of leave in place. We let them exist in a state of failure, dysfunction, and then that creates a block for us to be able to create value in where it could be. So, for instance, let's take an example of this and say that, you might identify one of your barriers in mathematics instruction as being a lack of understanding. There's a lack of understanding of some of the key tenets of good curriculum. So as you're trying to make choices in the flipped environment, there's lots and lots of mathematics curriculum out there available for schools that want to flip. How do you pick what you want, and what are the good tenets of good curriculum? And so if there's either a failure in thinking about what good curriculum is, a failure of understanding about it, then it's going to be really hard to pick good curriculum. Another barrier would possibly be that maybe that you're making poor choices within the curriculum. So there could be a failure of mathematics instruction because of poor choice of curriculum or poor choices within that curriculum. So we see that, we'd have to begin to understand that as a failure in action, and that, to go ahead and identify what the root cause of that is so that we can get rid of that blockage and then create value. Okay. Now, I've gone ahead and sort of classified barriers to sustaining improvement into 6 general areas. And they kind of will help you to think about how this is all sort of interconnected, and that really anything that you're taking a look at as an instructional leader in terms of instruction or sustaining some kind of instruction or getting at some kind of instructional improvement, it's really all a part of a system. So we do have to begin to think systemically and think about, if you remove one barrier, what does that mean for another element in the system? So this list of 6 items here actually represents a system, an organizational system. And so if you have a failure in one of them, it's going to cause problems all the way through. But let's take a look at what each one of these are individually. So let's say that there is perhaps in mathematics instruction in your building a lack of shared essential ideas. Now, I know that there are a lot of different ways that mathematics is thought about. What should mathematics instruction be? What is it? What does best practice tell us? What does research tell us? And so, if there's not a good understanding of that, you might be lacking just some core essential ideas about mathematics instruction. And another thing then is that maybe there's a lot of ideas out there about what good mathematics instruction looks like, but there's a failure to enact those. And so there may not be enough essential key actions happening in the classroom to bring this forward. And the other thing about this is that, we're kind of looking for this to happen on a collective level. So these would be shared essential ideas and shared essential actions about what good instruction looks like in mathematics. A couple other problems that you might run into are that there isn't a shared culture. There's a lack of routine or processes or protocols. There's been a lot of work done about some of the culture around mathematics in terms of gender bias regarding males and females and what that might mean. There might be just a simple lack of understanding of certain learning routines that could be very easily introduced to students to help them to understand some basic concepts of mathematics and so on. So if those things are missing, again, we're talking about just some simple core essential ones that are shared within your building and used in mathematics instruction. Another problem that we run into are standards, and not so much anymore because there's been so much work that has been done by the National Council of Mathematics Instruction regarding standards, and of course the Common Core state standards, and whatever happens within your state in terms of requirements for the curriculum expectations and so on. So mathematics standards are actually becoming quite clear now in education, even over the last 10 years, a lot clearer than they've ever been. So this maybe isn't so much of a problem unless that people don't know what to do with the standards, and then that has to be translated into some kind of institutional educational practice. And 2 other problems that sometimes we see is that we're not getting the information we need from assessments and audits, and that information isn't being shared in a way that helps us to sustain and drive improvement. And the last thing is that, this may seem like the most obvious of all, but sometimes we don't even know what we're trying to accomplish with instruction. Really, what are the final deliverables? What are we talking about here? I mean, do we want a student who has a good basis of mathematics? Do we want a student who's more application-oriented with mathematics? Do we want a student who just has a general liberal arts education? Do we want a student who actually can understand mathematics and how to apply it technically in a vocational sense? So to be clear about those deliverables. Now, you may have, in going through this list, you may be able to relate to one or two of these barriers as possibly being a problem in your school. But that's the great thing about this, is that identifying the barrier is a really good thing to do, because it doesn't mean it gives you an excuse, but rather it creates a very clear point of improvement. So if you find there's a lack of any one of these, that gives you an opportunity to create that through an improvement process. So maybe you need to create some more shared essential ideas, just core key things about mathematics instruction, or some of the actions that are taken in regard to mathematics instruction. Maybe there are pieces about culture and routines or processes, or maybe more clarity about the standards. Maybe you need to do some different kinds of assessing, or use assessment and audit data in a different way to be more informative and help to drive improvement. Maybe you just need to be clear about what are the deliverables of mathematics instruction. So anyway, as you work through this idea of examining what some barriers are, in the other videos in this series, I'm going to introduce you to a tool called the 5S. And it's a very simple visual process that will take you through 5 steps. That's why it's called 5S. Of sorting, setting, shining, standardizing, and sustaining. And it's just kind of a nice roadmap for you as an instructional leader to follow in terms of getting through this process of actually being able to keep in place things that are working well in your building. Well, I hope you've enjoyed this video. If you want more information on flipping or instruction or improvement, please go to the Flip Institute website at theflipinstitute.com. Thanks for listening, and I hope you enjoyed the video.